Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutewa Sos Ogwabela Wemets. And without any further ado, let's look at what we have here. So in today's topic, we are looking at trigonometry, general solutions, and what we see here is normally how you would solve your general solutions. So basically, if you have sine of angle A is equals to sine of angle B, within the first quadrant, that's where your sign is positive. So to solve in the first quadrant, you'd simply drop down your angles here because we have the same trig ratio on the left-hand side and also on the right-hand side. So you'd normally just say A is equals to B, where your B here would represent the reference angle. Then you need to say plus K 360 degrees because the period for any sine graph is 360 degrees. Then, okay, now this one would be the equation that you use in the second quadrant. So remember, with this one here, we are looking for all the quadrants where sine is positive. So that's within the first quadrant and the second quadrant. So the reduction formula that we use in the second quadrant is 180 degrees minus B. So we never get to use the 90 degree plus B when working with general solutions. So that's the one thing that you need to note there. And then again, if we look at sine where it is negative, we can see that's within the third quadrant and also in the fourth quadrant. Therefore, the reduction formulas, as we can see here, they represent the third and the fourth. So that would be 180 degrees plus B, where B is the reference angle. So 180 degrees plus the reference angle plus K 360 degrees. And then here, that's 360 degrees minus the reference angle plus K 360 degrees if it's in the fourth quadrant. Again, for cos, if we are looking for where cos is positive, we know that's within the first quadrant and then also in the fourth quadrant. Hence, we can see the reduction formulas. In the first quadrant, do not ever use the reduction formula that goes 90 minus theta. So all you just do in the first quadrant is you take your reference angle as it is, and then you just say plus K 360 degrees, as simple as that. Then in the fourth quadrant, that's where you need to say 360 degrees minus the reference angle plus K 360 degrees. Then for where it is negative, we can see that's within the second quadrant and also the third quadrant. That's where cos is negative. So as we can see with our reduction formulas here, they represent the second quadrant and also the third quadrant. So that's 180 minus the reference angle plus K 360. Here, that's 180 plus the reference angle plus K 360. Then lastly, we have tan. So where tan is positive, it's within the first quadrant and also the third quadrant. As you can see with our reduction formulas, we have a B plus K 180 degrees. Remember, it's 180 degrees because the period for tan is 180. So note that for tan, that's where we have K 180. But then for both sine and cos, we have K 360. So it's very important to note that. Now we have A is equals to 180 degrees plus beta in the third quadrant. Then where we see our tan being negative is within the second quadrant and the fourth quadrant. So as we can see with our reduction formulas here, 180 degrees minus the reference angle plus K 180, 360 degrees minus the reference angle plus K 180 degrees. So, okay, that's basically how you solve your general solution. So you need to know this 6 main equations here, right? Okay, so let's get down to a question here and see how we can apply this. So we have a question here that says determine the general solution for the following. We have sine 3x is equals to sine 2x, right? In this case, we can see that we have both the same trig ratios in the left-hand side and also in the right-hand side. So that means that this calls for us to just drop the angles right there. And then immediately you term this your reference angle, right? So note that. So all you have to do is just drop this 3x is equal to 2x, and then you term this your reference angle. Now you have to go to the respective quadrants. So remember, first we have the first quadrant, whereby all you need to do is just say 3x is equals to 2x, and then plus K 360 degrees, right? But then obviously you'd have to solve for your x. So that means you have to take this 2x over to this side, and then it will give you x. Now, if you take this and transpose it over to that side, you are only left with 0 degrees here. then plus k 360 degrees, and then you'll say where k is an element of integers. But then that's not where sine is positive only. We also have sine being positive in the second quadrant. So in the second quadrant, we have to say 3x is equals to what? 180 degrees minus the reference angle, which is 2x. Then we want to say plus k 360 degrees. Now this negative 2x will jump over to this side, and then it becomes 5x. And then that's 180 degrees plus k 360 degrees. Now in a position like this, what do? You need to divide throughout by 5. There's 5 here, so that you are only left with x is equals to. So everything including that period there. So this is x is equals to. Now in your calculator, you just simply press that. So what's 180 divided by 5? You find that it is 36 degrees. So we're going to have 36 degrees. And then 360 divided by 5, that's 72. So k 72 degrees, where k is an element of integers. And that's basically how you would find your solution. So this was suggesting that we need to check where sine is positive. So it's within the first quadrant and the second quadrant. Okay, so now coming to number 2, you have sine 3x is equals to cos 2x, right? Now with this one, we can see that the trig ratios are not the same. And again, the angles are not the same here. In a situation whereby the trig ratios are not the same and the angles are not the same, this is normally what we call a cofunction type, right? So this is a cofunction type. So that means we have to change this one here and write it as similar as that to have the same trig ratio. Now remember, according to our cofunctions, we know that cos 2x can also be written as sine 90 degrees minus 2x, right? So if we can just replace the cos 2x by this, then this is what we end up having. Sine 3x is equals to sine and then 90 degrees minus 2x, right? Now we can see that both sides we have sine and sine, meaning at this point we can just simply drop the angles. This is 3x is equals to 90 degrees minus 2x. At this point, you don't solve. You simply name this your reference angle, right? Then you go to the respective quadrants. Okay, because here we are looking at this being in the first quadrant, then that means we are looking for where, as we can see here, it is positive, right? So we are looking for where sine will be positive. Note that you found your reference angles by making this sign. So that means you have to find your solution where sine is what is positive, right? So we are dealing with sine because that's what we use to find the what? The reference angle. So sine is positive in the first quadrant and also in the second quadrant. The solutions in the first quadrant will simply just be 3x is equals to the reference angle plus k 360 degrees, right? So at this point, we need to take that over to the side, which becomes 5x is equals to 90 degrees plus k 360 degrees. Now to get rid of this 5, we divide by 5 throughout. Divide by 5 throughout. So this is x is equals to 90 divided by 5. This will give us what? 18 degrees. Then plus k 72 degrees, where k is an element of integers, right? Then within the second quadrant, we're just going to have 3x is equals to what? Remember, the reduction formula in the second quadrant is 180 degrees minus the reference angle. So you subtract that whole expression there. Remember, it becomes your reference angle. So minus in bracket 90 minus 2x. You have to be very careful about this. And then plus k 360 degrees. Now you have 3x is equals to 180 minus 90. That's 90 degrees. And negative times negative, that's positive 2x. And then plus k 360 degrees. Now, if you can bring over the 2x here, that's 3x minus 2x, which will just be x is equals to 90 degrees plus k 360 degrees, where k is an element of integers. So once you have x here, then you are done, right? So these are the two general solutions that you have in the first quadrant, 18 degrees plus k 72 degrees, where k is an element of integers. In the second quadrant, 90 degrees plus k 360 degrees, where k is an element of integers. Okay, so now let's look at the third one. With the third one, we can see we have a sine 3x is equals to negative sine 2x. Now you can solve this using two cases. Because this is negative, it shows that you must find your solutions where sine is negative, right? Now, if we go back to our cast diagram, we know that sine is positive where? In the first quadrant and in the second quadrant, but it is negative in the third and the fourth quadrant. So this is for sine. So that means the solutions that we are looking for are in the third quadrant and also in the fourth quadrant. In the third quadrant, we have 180 degrees plus theta. And then in the fourth quadrant, we have 180 degrees, 360 degrees, pardon me for that, 360 degrees minus theta, right? So these are the reduction formulas that we have within the third and the fourth quadrant. So now what we're going to do is, if we tackle this within the third quadrant, our case one will be sine 3x, and then we have to change this. Remember, it's negative, so we know that it will be negative within the third quadrant. So it's going to be 180 degrees plus 2x. Remember, we now treat that 2x as the reference angle. So it's 180 degrees plus that reference angle. Now, at this point, we can see that we no longer have a negative. Remember, you cannot drop the angles when you still have a negative here. So which is why we are doing this. We cannot treat it like this one. You saw with this one, we just dropped the 3x and the 2x because they were both positive. But in a case whereby one is positive and the other is negative, then you have to make it positive here by simply representing the negative in terms of a quadrant, right, where the trig ratio is negative. So now because we have sine x and sine x here, both positive, we can now drop this 3x, and then we have 180 degrees plus 2x. And then we need to say what? Plus k 360 degrees. Now, solving this, we have to take the 2x over to the side, which will leave us with x is equals to 180 degrees plus k 360 degrees, where k is an element of integers. So that's within the third quadrant. Now, within the fourth quadrant, again, we're going to say our sine 3x is equals to what? Now, we write this in terms of the fourth quadrant. So it's going to be what? 360 degrees minus the reference angle 2x. So minus 2x. So this is going to be what? We're going to drop down the 3x and then also drop down the 360 degrees minus 2x. Then we're going to have plus k 360 degrees. Now we have to take this negative 2x over to this side, which will give us what? 5x, because it's going to be 3x plus 2x. Then we have 360 degrees here, plus k 360 degrees. And in order to solve this, we have to divide throughout by 5. Divide throughout by 5, then we have x is equals to what? 360 divided by 5. I believe it's 72. So that's 72 degrees plus k 72 degrees, where k is an element of integers. And that's how you would have your general solution right there. So, okay, basically that's how you were supposed to answer those questions. So make sure that you come back to this video, watch it as many times as possible, and just try to understand the approach that I took into solving this. If you want to book any one-on-one session to better understand this topic, my numbers are on the screen. You can just WhatsApp me and then we can organize a session for you. Awesome.